Okay, so 11.4, now we're going to be talking about parallel and perpendicular lines. So parallel perpendicular lines, what it means when something is parallel or perpendicular to another, and we have theorems for those as well. Now, just as a reminder, these theorems that have numbers but they don't have names, are you required to memorize the number of each one? No, you just have to be able to explain to me the reasoning. So in a proof, basically what you end up doing is kind of writing out the definition of the theorem. The special ones with names are the ones where you just have to put the name. You cannot invent your own names. Don't do the number because I don't have the numbers memorized. I don't know why they don't name them all. I think because some of these things, they're like not commonly used, or they're simple logical things like alternate angles theorem or alternate exterior angles, like that gets used a lot, and so they just give it like a special name.
Or maybe it's just because mathematicians and scientists are super lazy.
That's sometimes true. Okay, here we go. So these are all new, but they all should be kind of make sense. So you like just like our postulates, they should all you should kind of just be like, well, yeah, duh. Okay? So if two lines are parallel to the same line, then they are parallel to each other. Yeah, duh, right? Okay? So this is saying that if I tell you for sure that line B is parallel to line C and line A is parallel to line B, then what can we say? A is parallel to C. That's right. Yeah, duh, right? Okay. 14. In a plane, if two lines are perpendicular to the same line, then what could we say? They are parallel to each other. So, if line M is perpendicular to T, and line N, as in Nancy, is perpendicular to T, then we can say that M is parallel to N. Duh, right? Okay. So, we're going to do a couple problems. A carpenter plans to install molding on one side at the top of the doorway. So that's like crown moldings. Do we have crown molding in their house? That it's like the border. So in some houses, along the top, they have like the molding that goes across. Usually it's in a different color. It's baseboards for the ceiling. And sometimes people put molding around door frames to frame the doors too.
It's like swirly.
It makes it fancy. It makes it fancy. Yeah. So a carpenter plans to install molding on the sides and the top of the doorway. The carpenter cuts the ends of the top piece and one end of each of the side pieces to make 45 degrees as shown. Here's the question. Will the side pieces of the molding be parallel to each other? What do you guys think? Will the right side be parallel to the left side? Yes. Why? Who can tell me? They're both perpendicular to the top. Lily, how do you know they're perpendicular? Yes. Very good. So if this is 45 and this is 45, when I put them together, what kind of angle is it going to make? A right angle. If this is 45 and this is 45, when I put it together, what kind of angle is it going to make? A right angle. So let's answer that. Yes. The sides will be parallel. Because, and I'm going to use what you said, when you fit the pieces together, they form what kind of angles? They form right 90-degree angles, it doesn't matter. Right angles. Right angles. Since each side is perpendicular to the top, they are I'm sorry, I'm running out of space. Parallel to each other. Okay. Oh, I know that made it all the way down to the bottom. Okay? So, we answered the question. Yes, the sides will be parallel. We explained why. When you fit the pieces together, they form right angles. And by definition, right angles mean perpendicular. So since each side is perpendicular to the top, they are parallel to each other. Okay? 3 sentences. Not too bad. Number 2, you are building a trellis for vines to grow on. Everybody know what a trellis is?
Yeah.
Okay, a trellis is like a wood, thin pieces of wood frame for that vines grow on. So like climbing vines. A lot of times they look like, this is only part of one. A lot of times,
Wait, you mean those things in like movies when like the boyfriend's trying to sneak out of the house?
yes, exactly. Okay, but in like, so,
Or High School Musical.
like usually they form diamond patterns. Like that.
I feel.
Okay? Okay, so you're building a trellis, and the completed trellis will have 2 sets of diagonal pieces of wood that overlap each other. So it means they have this part, and then they're going to put another one going this way, just like I drew. So they're overlapping. So they're going to form a diamond pattern. If pieces A, B, and C must be parallel, so these are parallel, what must be true of angles 1, 2, and 3? What do you guys think? They are all congruent. So let's write that out. Angles 1, angle 2. That's the weirdest 2 I've ever written. 2. And angle 3 must be congruent. Is that a complete thought?
Yes.
Yes. Okay. So then part B, you attach piece D, so piece D is already shown, so that it is perpendicular to piece A. So they make a right angle. If you want to place more pieces that are parallel to D, how can you do so? Justify your answer. So how could I add the more pieces and ensure that for a fact they are parallel to D?
Make them perpendicular to A, B, or C.
Make them perpendicular to, and let's just say specifically A, since this references A. So write that in a complete sentence. So to whatever you want, your own sentence, go. So I said, to ensure pieces are parallel to D, attach them so that they are perpendicular to A. Because the corresponding angles will be congruent, the pieces will be parallel. You might have used different reasoning. Yeah, if you use theorem 14 that said because the pieces are perpendicular to the same piece, then they must be parallel, that is fine too. Okay, there's lots of different reasons. Not too bad? Okay, so the last theorem says that in a plane, if a line is perpendicular to one of 2 parallel lines, then it is also perpendicular to the other. So if I tell you that L and M are parallel, we know that because of these marks. And we know that N is perpendicular to L. We can also say that N is perpendicular to M. So N perpendicular to M. That's the symbol for perpendicular, because it makes perpendicular lines. It should. Okay, so we're going to do 3 proofs I gave you guys more spaces than you might need. Some of them might take up all the spaces, some of them might not, and we're going to do both sides. The reason I did that is because I talked to the Math 2 teachers, and they said that on your tests, when you do tests with proofs, sometimes you can do a proof in 5 lines, and they give you 7. Okay, so you don't always have to fill up all the lines. So let's look at this one. Given. In a plane, C is perpendicular to B, B is perpendicular to D, and D is perpendicular to A. We want to prove that line C is perpendicular to line A. Now, I will tell you that some of the information might not all be used at all times. So let's think about this. I want to prove that C will extend and be perpendicular to line A. So, and makes a right angle. So I know that if C and B are perpendicular, and B and D are perpendicular, I could say that C and D are what? Parallel. So let's write that. So we'll start with the given statement. I'm not going to put all 3. I'm just going to use these 2 right now because that's all we needed to prove that the 2 lines were parallel, right? So we just used that C is perpendicular to B, and B is perpendicular to D, and that was given. Sometimes you're given too much information, or you're given information that you won't use until later. So you're not always going to put the whole given statement first. So then what did we show? If C and D are perpendicular to B, we showed that C is parallel to D. Okay? And we just kind of summarized the theorem that says that. So we would say don't write theorem 15 because I won't have theorem 15 memorized. I want you to explain it. So it says 2 lines that are perpendicular, or let's even do 2 lines perpendicular to the same line are parallel. So you can use symbols, that's okay. So 2 lines perpendicular to the same line are parallel. Okay, so we just showed that C and D are parallel. Do you think that's going to come in handy for us? Yeah, because I also know that D is parallel to what? A. So let's write that. So D is perpendicular. D is perpendicular to A, and how do we know that? Given. So is that enough to say that C is perpendicular to A? We already proved C and D are parallel.
You need to prove that A and B are parallel, right?
It doesn't matter. It doesn't matter because we already proved these are parallel. So if these are parallel and line A is perpendicular to one of them, isn't there a theorem that says it's been perpendicular to the other one? So we can say that C is perpendicular to A. And the reason is that one had a name. Perpendicular transversal theorem. That's theorem 15. Okay. So it's saying that if I have 2 parallel lines and one is perpendicular to the transversal, then the other one is also perpendicular to the transversal, right? So that is enough for us to say. Not too bad, right? Okay, and we didn't have to use all the lines. So remember, yours might be different. That's okay, as long as it makes sense. So I'm going to show you what I did, and it should be at least a good guide of what yours should look like. So I used that line L is parallel to line K, and I said that was given.
I don't like that color. It's nice on your iPad, but like,
It's fine. So we know that L and K are parallel. So therefore, if these are parallel and I have the transversal, what can I say about angles 1 and 2? They're corresponding, which means they are congruent. So angle 1 is congruent to angle 2. And that is the corresponding angles theorem. Oh, actually, you know what? I did use the other one. That M is parallel to K. Just kidding. Okay. So then, since M is parallel to K, I can also make a statement about angle 1 and angle 3. What is that statement?
that
So if you're using measure, they're equal. If it's just congruent, we would just say angle 1 is congruent to angle 3. Why is angle 1 congruent to angle 3? Same reason, corresponding angle theorem. Is everybody with me so far? Do you kind of see where I'm going with this? A little bit? Okay, so what else could we say? That angle 2 is congruent to angle 3, and what property is that? Transversal. Or transitive, sorry. Transitive prop of congruence. Okay, so therefore, if angle, so here I'm going to erase this. If angle 1 is congruent to angle 2, and angle 1 is congruent to 3, so all of these are congruent, and angle 2 and 3 are congruent, then L and M are parallel because of the converse of the corresponding angles theorem. Okay? I know. That's the point. I know. I know it's hard. That's the point. Okay, so the actual number 5. Yeah, it says 4 on there, but it's really 5. Let's just change it to 5. So in the plane, A is perpendicular to B. B is perpendicular to C, and C is parallel to D. I want you to prove that A is parallel to D. So that is saying, that's proving the, if two lines are perpendicular, parallel,
Is the perpendicular transversal theorem?
I think, yes.
Number 14.
We are proving theorem number 14. No. We're proving perpendicular transversal. Okay? So I want you to try it. I did it in 4 steps. There's your hint. Okay, here we go. So let's start with the given statement. A is perpendicular to B. B is perpendicular to C. And C is parallel to D. I'm going to use all those. Given. Okay. Oh, wait. I used C perpendicular to D elsewhere. Okay, here we go. If A is perpendicular to B and B is perpendicular to C, what can we say about A and C? They are parallel. So A is parallel to C, And that is 2 lines perpendicular. 2 lines perpendicular to the same line are parallel.
I feel like these symbols should just be letters.
I know.
Because it looks like 2 L's and then the upside down T.
Well, these are 2 parallel lines, and this is a perpendicular line. It's just how it is. Okay, so then we know A and C are parallel. Now, we also know that C and D are parallel. So what could we say about A and D? But we have to do the in-between step. So we have to say that C and D are parallel, which is given. And then we can go straight into A is parallel to D. Why? Christian.
I put 2 lines parallel to the same line that they are parallel.
Yep, 2 lines parallel to the same line are parallel. Done. Who got that all on their own? Good job, you guys. I know it's tricky, but with some practice, it's starting to get easier, so you're doing a good job.